I can be intrinsic geometry, exterior algebra in 3 dimensions. As I mentioned before, this can be expanded for 2, 3, 4, 5 in any dimension. You see? Now, item B, part 1, manifold. B, part 1, lecture 15. Now, transition function. Now I will consider 2 different manifolds, M and N. Could be a different dimension, okay, M and N. Okay. Now, let's given. Given point P belong to the manifold M. You see, this point here, recall, I have a point here, I have the scalar lambda, the real number. You see, I have this function gamma of lambda. This is 0, this is minus epsilon, this is plus epsilon. And these are the coordinates of the point B belong to the manifold. Okay, I'll call this point as x1, x2. So I have to have a gamma of lambda, okay, which in this case I'll apply to the manifold M2, just to as an example. You see? So suppose I did that and I have point P. Okay? So I will draw the manifold here, M, and this is the point P. Okay? Point P is x1, x2. In 3 dimensions, it will be x1, x2, x3. See, so this point P. Let's put this none. Okay. Also, I'll give the map F. Let's go here. The map F. Okay. Now it's important because F is given, also given. Okay, or known. It's better known. Okay, known. That's a map F. This map, okay, this is mapping. This is a manifold N, and this is a map F. This now is my point Q. Okay. Q belongs to the manifold N, and P belongs to the manifold M. You see, Q is a consequence, okay, because F is given, okay, P is given, okay. Now, what I will do now, you see, I will erase here. This is known. Okay, I can erase. This I consider over here the map. I'll call alpha x. You see, and then here I have phi1 and phi2. Okay, then I map this point over here. I'll call this P prime. See? P prime. So I map with alpha of x as a linear mapping, okay? Then I have to mark the point B prime. So P prime is a consequence also. Given alpha x sub x, I apply to point P and I get this over here. Likewise, when I calculate the coordinates of point Q, you see, I say that point Q here, point Q is y1, y2. That's point Q. This is a consequence, okay? I have point P, I map using f function, and I obtain the point Q. Now, I'll do analogously, I have here my alpha y, you see? And then this alpha y, okay, leads to C1, C2, and this is my point Q prime. See? Q prime. Now, if you remember, you see, I can construct, okay, that's a chart just using alpha x minus 1. So I have a chart over here, okay, because you see now I'm in a region, okay, very close to P. So this is my chart. I call chart, let's say U, okay. Also here, if I map with alpha y minus 1, the inverse, you see, I will have here, I'll put another color here just to make more clear. You see, then I'll have this, I'll call V, you see? So this is a chart, okay? Remember that this chart, okay, points of this green chart here, they are x1 and x2, but approximated points, okay? Analogous on this point over here, okay, because they belong to a map from this case, okay, from here to get point Q. Now, again, what I want here, I want the transition function here between P prime and Q prime. You see, that's what I want. I'll put it here, Q prime. You see? Now, there is a way to do it, quite easy, okay? Look, what I want is from P prime to Q prime. So there's a trick here. You put here P prime. Now, I walk, you see, P prime to P, I must use alpha x to minus 1. So I'll put over here, okay? This is P prime. So the next here, okay, I compose, okay, with alpha x minus 1. Okay, if I compose P prime with alpha x minus 1, I already obtain point P. Now I compose with F. So I compose with F. Okay? So then I'm here. And now I compose with alpha y. Okay? This here give me the point Q prime. You see, it's quite easy for you to see it. I want to go from here to here. Now, I cannot use points on a manifold. That's a trick. I insist in saying that. So I use okay, this path over here. From here to here, I'm repeating. Alpha x minus 1, the inverse. From here to here, I apply the function f. And from here to here, I apply this linear mapping alpha sub y. That's why I relate this point here with this point over there. It is this, the transition function to manifold MAN. Q prime, don't forget, Q prime belongs to N. And P prime belongs to M. See? So if I want the inverse, okay, I just write here first. I'll write Q prime. See? I'll write here first Q prime. So the inverse, I'll write here. The inverse. So now I want from here to here. Let's put another color here, just to suppose I want from here to here. So then I write down my Q prime. You see, Q prime. Then the path from here to here, I go this way. So this composes alpha y minus 1. Alpha y minus 1, I get point Q. Now I use, attention now, F inverse. F inverse.